Hello, this is a new tutorial. I'd like to talk about two important elements. The first one is a continuation of previous project related to VR lighting. So I think I'd like to talk a little bit more this time to describe the different way you can use PCVR with Lumen. Okay. So in the previous tutorial, I covered there's a very conservative mobile VR. Start with a mobile VR template. You can also do the non-VR, which usually has this global illumination with Lumen, reflection with Lumen. And also you can do a hybrid. So when you're using PC VR, instead of follow the mobile VR, you can have Lumen activate. But as I mentioned, this will be very expensive in terms of the GPU computing time. You might have a low frame rate. So as the solution, you can set scalability to low, which is equals to 2, which will make the Lumen still work, but you are not getting too much highly detailed global illumination. It's dialed down the performance, dialed down the quality in order to get a better performance. And also because you are using Lumen, you are able to use all the dynamic movable objects, dynamic lighting, dynamic shadow. So when you're interacting with your hand, you can see the hand will cast the shadow as a dynamic way. So this is the PCVR with Lumen. An alternative way is using PCVR without Lumen. So basically this is kind of follow the mobile VR solution. You deactivate the lumens through post-process. So the global illumination is none. Reflection, instead of using lumen reflection as the PCVR with lumen settings, you want to do screen-based, which is a very old school but very fast screen-based reflections. So this will be without lumen. You can still get some reflections, but no global illumination. And also in this case, you probably want to pre-compute all the static lighting, and all the light information will be baked into the light map, right? So these are the settings you wanna try. I also want to mention is this options called allow static lighting in project. This should be equals yes in both cases. Okay, I think this case could be no. Yeah, because you are not really baking anything. So let me get rid of this. Okay, so this will be the condition close to mobile VR. So let's go back to Unreal. I will show you a little bit. Right. So first, how you disable Lumen. By default, in the project settings, in the rendering session, if I go there, you can see the global illumination by default, right, is using Lumen. So this one is on. And also, if I go to reflections, right, this is a Lumen reflection. So this is the project wide. However, if you have an individual level, as I mentioned earlier, you can create a post-process volume, right? And in this volume, in the details, you are able to override the project setting. So for here, if I go to global illumination, you can see here I set this to none, right? I'm not using global illumination with Lumen. I'm using no global illumination. And also if I go to reflections, you can see the reflection instead of using Lumen, I'm using screen space. So this is a much cheaper way to compute the reflections. So you can actually see the reflection right here. Right? This is a screen-based. It's not very accurate, but it's very fast. You should also remember, if you do want to create a screen-based reflection, you want to create a reflection probe, right? This sphere which capture the reflection. The way you can do that is go to reflection, then you can create a reflection capture sphere. Okay, so that's just give you this nice reflection. screen based. And also don't forget, if you do use post process volume, you do want to make sure your bound, right, is checked. So this is called infinite extent. So this post-processing will be applied to the entire level instead of just one volume. Okay, so by doing so, if I go back, you basically achieved override the project settings, right, of Lumen. So Lumen is disabled. Another couple of things you want to make sure is you want to change your lighting and shadow, right, to pre-baked. So here, if I check my current lighting, just want to show you. So my directional light right now is stationary. My skylight is static. My point light is static. So this point light is right here, right? And this point light is casting the shadows to the ground. You can see the shadow right here. You do see this right, notice that lighting needs to be rebuilt, right? The reason is I'm just synchronized from the GitHub, so my local build is not up to date yet. So I need to recompute the static lighting. The most important part in this level is actually the ground. So in the ground, if I type light map, I checked the light map resolution to 1024. This is much higher than default, which will give me a little bit sharper shadows on the ground. Okay, so just make sure you can override the light resolution here. And also, for some reason, if you don't like the original baked light, you can always go to the world settings, and then you can see there's a light maps. Here's a place you can delete the original light map. Okay, you just check force no pre-computed lighting. Check this, then all the shadow will be removed. But anyway, I'm going to actually build the lighting. Okay. Well, another thing I forgot to mention is this entire building. You see this entire building, I rotate 90 degrees because I think the original opening is facing the sun, or the sky is just too bright. So I rotate 90 degrees to make it relatively dark. Not much sunlight can go in. I also check the details in the light map. Right? If you type light map, you can see I changed this light map type to force volumetric. I think by default it's gonna build the lighting shadows to the building. However, this will be a problem. The reason is this module has a double-sided material. What I mean is, if you look at the wall, this wall is a paper thin, right? There's no thickness. This is achieved by the double-sided material. It looks okay, but when you build the lighting, the negative face will be black because there's no UV mapping, lighting information for the negative UV. So in that case, you want to change the light map to force volumetric. That will exclude this module from the build. Just one trick. Okay. So now let me go ahead and build the lighting. You will see it takes some time, and you can see the shadows on the ground, right, which is baked light map. However, you will not see the shadow on the wall because the wall is already being excluded from the force volumetric. Okay, so let's wait a little bit until the light finish the build. Yeah, because we are doing a higher resolution, this will take a little bit time, but it's totally worth it. That's the whole point about pre-computing light, right? Because all the shadow information will be pre-computed right here, right? You don't want to allocate any GPU time later to do the computing. See, the shadow looks pretty good. If I look at the wall, right, there's no baked shadows on the wall, just simply because this is excluded from the light map because it's volumetric, something like cloud, right? Okay, so we have this lighting baked. So this will be the most efficient way you deal with the light and shadow is to pre-bake all the information here. All right, as a refresh, in this PCVR without Lumen, we use post-process disabled Lumen. We disabled Lumen reflection. We use screen-based reflections. We baked the static light. Okay, so now if I play in VR, okay, I will show you what this looks like. Right, you can see the scenario looks pretty good. The frame rate is very high. If you wonder how I can know the frame rate, I can use in the console command. I will say stat frame per second. Right, as you can see right now I achieved 44, 43 frame per second. That's pretty okay. Okay, and now if I grab the torch, right, I'm able to apply the particles. You see the frame rate drop a little bit, but it's still pretty good. Okay. I also want to tell you, because I'm doing the video recording, screen capture at the same time, so it's lost some of the GPU power. But in general, it's pretty nice. Okay, that's how you do the high frame rate with the PCVR. Bake the light without Lumen. I also want to show you is this is a welding VR training. So I want to create a simulation is when you grab the mask, it's actually gonna switch the post-processing to a different color, right? As you recall in the last tutorial we covered, you can change color offset, you can control exposure, right? You can make the rendering looks totally different. So here, if I play one more time, just show you. So I have 40 frames per second. During the recording, it's not too bad. Okay, I think I have to do it again. Okay. All right. So I have the my mask, right? You can also see the reflection right now is based on the screen-based reflection. Right, it's not a Lumen reflection, but it's still pretty good. I can navigating here. All right, so if I grab the mask, right, immediately the environment became green, right? So that's kind of representing the filters through the mask. If I grab again, it's going back to the original one. Grab again, it's going to green. Grab again, it's go to the original. In both cases, you always see the reflections of the table. Yeah, so this is just a way you trigger the mask. Okay, so I will show you a little bit how I did this with my mask actor. So here, if I browse to asset, I can see this mask actor. If I open it, you can see it has a really simple 3 components. The first one is a post-process variable. By the way, you can create a variable by adding one, give a name, then in the type, you can type post-processing, right? So you can set post-processing settings, so which is the PPO and the PP1, right? So this is the 2 process settings. You can also do the post-process component, which will link to object reference. So this is a different thing, which I did for this guy, PP instance. Right? Let me delete this guy. Right. So the PP instance, I make it as public. So that means when you drag this to the level, in the details, you are able to control which post-process volume you want to load. So I'm just loading the current one in the stage. Right. This is the only one I have, which is this called post-process volume, this guy. So that's how this mask is able to communicate with the post-process volume. And if I go back here, once it's recognized this one as the default, right, then we can do a few things. So first, I can set this guy's setting with a predefined PP0 and PP1. So PP0 basically, when I initiate, I will give a comment, when I initiate the mask assign current post-processing setting to PP0. Right, so that's basically what it's doing. It's just grabbing whatever the current setting is, populate PP0. Then I have another script. This script is called onGrabbed. So whenever I have a grab component of this mask, this grab component, you can refer to my torch tutorial earlier, has the value 90. This is supposed to be 90. The reason I have 180 is because if you pay attention to the mask, this mask is already being rotated 90 degrees, right? If you think about Z axis, it has a clockwise 90 degrees. So 90 plus 90 equals 180. That's how you can make the mask kind of follow the same trajectory like the pistol. So that's just some tiny tricks. All right, back to the event graph. So when I grab this mask, it will do flip-flop. So when you first time grab it, it will set the post-processing setting based on PP1. If you grab again, it will set to PP0. Right? So basically this means this will be swapped. Right? Swap post-processing settings between PP0 and PP1. Okay, so that's basically it. And you wonder where this green color come from, right? That is actually come from the PP1. So here, if I show you the color, you can see I did a little bit offset along the green 0.02. I also changed a little bit tint to make it greenish. So that's how you make the new settings as green. I also want to mention is in the global illumination settings, I kept this as a none. So this is not a lumen based, right? Just want to be consistent. And also if I go to reflections, this is a screen based reflection. So this all be consistent as the previous one. This is how the mask, if you first time grab it, it will turn on the green post-processing. If you second time grab it, it will go back to the initial PP0. Right? That is whatever the default is. Alright, I think that's all about what I want to cover for this tutorial. I do want to show you maybe a little bit really quick is why I did not using this option, the PCVR with Lumen, because I know as March 17, 2025 today, I think with Unreal 5.5, Lumen actually can work with PCVR, no problem. It's just the performance is not very good yet, but I'm pretty confident Unreal is still continue to pushing this forward. So maybe at someday the Lumen would be fully compatible with VR. So I can show you a little bit. If you do want to test the Lumen in the PCVR, right? You could turn it on. Just make sure the scalability you want to set it a little bit lower. So I will show you how to do it. And also the dynamic lighting. You can definitely change the light to dynamic. Okay. So let me change this really quick. So first, I will disable the post-processing. The best way to do that is in a bound, right? You just uncheck, right? So that means this post-processing will not work for the entire level. It only works inside this tiny boxes. Okay. So that's one. I will make the box a little bit further away so I'm not accidentally trigger it. Second is I want to change the light to make it dynamic, right? So this lighting right now is static. I want to change to movable. So immediately you see the bouncing light from Lumen. So Lumen is really expensive, but it compute all the lighting nicely. And also same thing for the directional light. I can make it movable. For the skylight, I can make it as movable. So all of the light is using the more expensive, high quality settings now. Okay, you'll see the baked shadow is gone, right? No problem. Then go back here. I already changed everything to dynamic. I already disabled the post process, right? So by default, Lumen is on right now. Then I want to change the scalability. So this can be done if I open the level blueprint. Right. I have programmed a very simple script. This is done through the console command called scalability 1. So this basically drops scalability to a really low value, value 1. It's actually not value 2. Okay, just want to be consistent. So when you trigger this custom event, this scalability will be 1. And the way I want to trigger this event is by press key number 2. Okay, so maybe let me just adding some comment. Change graphic to low. Okay, and then this will be trigger graphic change, right? And then I do have another one. It's called number 3. This is just basically my lazy way to activate mask, right? Because sometimes when you're testing, you don't want to, in VR you can just testing right here. So I have the number 3 key on the keyboard. When you press, I will grab the mask actor, and then I will trigger mask on off, which is this guy, right? Mask on and off. It's very similar like a grab. They both trigger the swap, right? Swap post processing. So that's my logic. Okay, so let's try that. I will play the VR. So keep in mind everything now is very high quality, but you're gonna suffer the frame rate for sure. So let's play. Okay. Alright, so immediately if you pay attention to the frame rate on the screen, it's about 20, right? Super low, 20 frames per second. It might feels okay, but definitely in a VR settings, 20 is a very very low frame rate. Okay, so that's 20 frames per second. But also you see the shadow looks different. That's actually not baked shadow here. The reflection looks very real, right? And if I move my head a little bit, I can definitely feel the low frame rate, the latency. So now let's press the keyboard number 2. Remember that? Yeah, number 2 will dial down the scalability to 1. So now I see it sacrifices a little bit of rendering qualities, but I think I can achieve a little bit higher frame rate, right? See the frame rate is increased to 50. Wow, that's actually pretty high, but the quality is not very good. Okay, so that's how these things can work. If I grab the mask, I'm not sure why this one doesn't work with a mask anymore. Oh, I see what happened. It's because we changed the post-processing volume to not infinite, right? So it's not able to see unless I jump into it. I think this post-processing volume is right here. Now you see the green. Okay, all right. So that is the demo. I just want to show you why I don't really typically using Lumen in VR is you have to sacrifice the scalability in order to achieve a better result. Okay, So I will actually reverse this. So I'm gonna go to the post process. Yeah, it's a good way you can see my doing this again. Then I'm going to the bound, right? And I will activate the bound. And then I will change my light from movable to static. Unfortunately, you have to rebake it. If I go to my skylight, change it to static, go to my directional light, change it to stationary. Okay, so this is all the lighting I changed. And let me see. Yeah, I think that's it. I changed my post process, I changed my lighting, and then I have to rebake it, which is okay. So I build the lights. Okay, so all the lumen thing is off. You still using the static baked light shadows. Okay, but we got a better performance. By the way, you can see here's a tag called scalability, right? If I click, oops, you can actually see I'm using the medium now. But definitely depends on your computer, GPU. You can do auto. So if your GPU is good, you're probably gonna see some settings as app. Oh, actually, I'm jumping to Epic. That's good to know. Yeah. So this is something you wanna play with, right? So let me save it. Save all. So when you save, you basically save the baked data into the level build data file, and you can see the shadow come back. And then if I play, I should get a pretty good frame rate. Just want to make sure. Yeah, we already changed this bound to infinite. Yeah, that should work. Play one more time. You see the frame rate right now is 40, pretty good. If I'm not doing recording, this frame rate can easily goes to 60. Right? If I look at the reflections, it's a screen based. It's not too bad. If I grab the torch, right, I can see the particle system. You can see a little bit of screen-based reflections here on the table. Okay, not too bad. Okay, and also if I grab the mask, I can see the green post-processing kicking. Okay, that's pretty good. Yeah, what I mean is everything is static lighting. If you wave your hand, right, you don't see the shadow of your hand on the ground because this is kind of static. You are not calculating the shadow from the hand in real time. But if you're doing the lumen, you can actually see the lumen gonna calculate the real-time shadows from the hand. It's not too bad. If you look at the reflections from the aluminum bar, you can start to see the your mirrors. If you wave your hand, you can still see your hand is moving there. If I grab the torch, yeah, you can see the torch in the reflection, right? Although it's not very super physically accurate, but you can sort of see the torch reflections on the mask. Put the mask right here. Right, maybe I should go to the other way. Right, you see the reflections of the torch, right, from the mask. Yeah, I don't think the particle has the reflections, but definitely the torch has. Good to know. The torch has reflections. Yeah, that's all screen based. Okay. All right, I think this is all for this tutorial. I hope this will let you be more confident when you work on the VR, is which option you want to use when you're using PC VR. In my opinion, for today, do not use Lumen. All right. Well, I just adding another few grabbable objects. So I go to this oxygen bottle. I change this to movable, and then I add a grab function by adding grab here. This is free. I also want to make sure this one has a collision, right? So if I click collision, I don't see anything. I probably want to create if you don't want to be a complicated one, just do a capsulate collision. So this will be the shape, or even the cheaper one will be the box collision. You can remove the current collision, you add a box collision. Right, this one will be the most cheaper one. Also did the same thing for this machine. So this has a grab function, it's free. This is the movable objects. It also has a box collision. So now if I play, I should be able to grab additional objects. So we'll see. Oh, I'm using the wrong hand. Okay, the other hand. Right. So here I'm able to go here. If I grab, this is free grabbing, so that means you can pick any point if you attach to your hand. Right. This is free grabbing. It's not a snapping. If I go back to the back, I can grab this bottle too. Right. I did not activate the physics, so this thing can actually float in the air in any way you like. Right. I can put them floating. I think I can grab this as well. This is a free snap, right? So that's a mask. Yeah. However, if you want to activate the physics, I think you can do that as well. This is in the details. I think I have to search simulate physics. You can also define the mass. I would just leave everything as a default. This one, maybe I want to simulate physics. I don't know, maybe this one I want to do as well. So now, if I play, right, let's see if the physics works. Oh, you see that that mask is already on the ground. That's interesting. How about this? If I drop, yep, he'll be on the ground. Pick this, drop. Ooh. Wow. So it's gone. Okay. Yeah, but shadow is still here. Huh? That's weird. Yeah, because it's a pre-baked shadow. Okay, so that's how the physics gonna kick in. All right. Yeah, I would just move this a little bit higher, so it's not, bouncing from the table by default. Still bouncing from the table. That's weird. It must be because there's another collision objects that already intersect with it, so it's push it away. Maybe. I can actually see maybe reflections. Okay. Detail. Well, there's a way you can actually turn on the display of the collision objects. Then you can troubleshoot, from the visibility collision, if there's something already collide with this box, with this mask. Okay. You might also do is, take a look at this mask, make sure this one has a collision. I will probably do a simple sphere collision. Oh, let's undo first. Oh, it already has a collision. So the collision is good. Maybe it has two collisions. Let's delete. So this is the sphere collision. Oh, it has two collisions. I will remove one collision, and then I will just add a sphere collision. Okay, so this is kind of like a shield, right? Okay, so now let's play one more time. If it's still bouncing around, I will just disable its physics. Okay. Oh, okay. Let's play one more time. Yeah, it's good. It doesn't bouncing around anymore. All right. Yeah, I think that's it about the simulated physics. Right, so it's kind of like a sphere. Yeah, that's all right. Okay, I think that's it.